4 launchers, 2 radar arrays, 1 reload crew caught in the open. The S-400 battery guarding northern Crimea's most critical logistics hub had been operational for months. It had never been touched. Russia believed it never could be. They were wrong. The first GMLRS-ER rocket arrived at Mach 2.9. The warhead detonated 8 meters above the transporter erector launcher's rear axle, directly beneath the missile canisters. The overpressure wave shattered the hydraulic mast. The canister housing crumpled inward. The second rocket, 4 seconds behind, hit the radar array. The third found the generator trailer. 4 launchers, gone in 11 seconds. This is how Ukraine's HIMARS crews reduced Russia's most advanced air defense system to a field of burning aluminum and tore open the sky over the entire northern Crimean supply corridor. I'm your host at EastAlert, where we analyze the battles that change wars. What you're about to hear is not a story about luck. It's about patience, precision intelligence, and a doctrinal problem that Russian engineers never solved. The S-400 Triumf was built to destroy incoming threats. It was never designed to survive becoming one. By the time this story ends, you'll understand exactly how Ukraine's General Directorate of Intelligence pinned a $1 billion air defense system in place, waited for the one window where it was most vulnerable, and delivered a salvo that doctrine specialists in Moscow still can't explain away. Let's start at the beginning. Dzhankoi sits in the northern neck of the Crimean Peninsula, roughly 65 kilometers from the administrative boundary separating the peninsula from Kherson Oblast. On any logistics map of Russia's occupation infrastructure, Dzhankoi is impossible to miss. It is the single most important rail junction in Crimea. Every freight train carrying ammunition, fuel, and military equipment moving south from the Russian mainland passes through Dzhankoi's switching yards. It's also the hub for the road network branching west toward Yevpatoria and east toward Feodosia. Russia understood this. Ukraine understood it more precisely. The Russian command had invested heavily in protecting Dzhankoi. Multiple echelons of air defense surrounded the junction. Older S-300 systems provided the outer ring. Pantsir S-1 short-range complexes filled the close-in layer. And at the center of the protective umbrella, covering the northern approach corridor with engagement envelopes stretching 400 kilometers, sat the S-400 Triumf battery that became the subject of this reconstruction. The battery consisted of 45P85 SM-2 transporter erector launchers, each carrying 448 N6E3 interceptor missiles. Supporting them were a 91 N6E acquisition radar, a 92 N6E engagement radar, and a 55K6E command post vehicle. Total asset value, approximately $3 billion US. Crew complement, 160 personnel across all elements. Which weapon was deadlier in the strikes on Crimean air defense? A. HIMARS rockets. B. Artillery. C. Drones? Drop your answer in the comments. We'll break down the numbers at the end. Russia had positioned this battery with attention to masking. The launchers were dispersed across a tree-screened ridgeline approximately 12 kilometers northeast of Dzhankoi's outer rail yard. The engagement radar sat on slightly elevated terrain with a clear line of sight across the northern approach quadrant. The command post vehicle was dug into a revetment 400 meters to the rear. From a Russian planning perspective, the position made sense. Tree screening reduced the optical signature. The elevated radar position maximized engagement geometry. The proximity to Dzhankoi meant any Ukrainian strike package targeting the logistics hub would have to penetrate the battery's engagement envelope first. What Russian planners didn't account for, or chose not to, was the consequence of the radar's own emissions. The 91N6E acquisition radar, in active search mode, puts out a distinctive signal. Signals intelligence assets can detect it at ranges far beyond the radar's own weapons engagement zone. Ukraine's GUR, working with allied SIGINT platforms, had been collecting this emission signature for months. Not just collecting it, mapping it. Building a behavioral model of when the radar activated, how long it stayed on, when it went into standby, and most critically, when the battery conducted its ammunition resupply cycle. Here is the problem that Russian designers built into the S-400 without intending to. The Triumf system's reload cycle is its most vulnerable moment, when a launcher has expended its missiles, or when a battery rotates missiles during maintenance. The transporter erector launchers must physically lower their mast assemblies to horizontal to accept new canisters from the support vehicles. During this process, the launchers cannot engage. The engagement radar keeps running. but the battery's killing capacity drops to whatever missiles remain on the other launchers, minus any simultaneous engagements already in progress. Ukrainian intelligence had identified the battery's reload pattern. Every 72 to 96 hours, the battery conducted a partial ammunition rotation. 2 of the 4 launchers would lower simultaneously while the other 2 stayed vertical and ready. The window lasted between 14 and 22 minutes, depending on crew proficiency and weather. 14 to 22 minutes. That's the window Ukrainian HIMARS crews needed. The GMLRS-ER rocket travels approximately 150 kilometers in under 180 seconds. A HIMARS battery positioned 130 kilometers from the target could put 6 rockets on aim points across the battery's dispersal area before the first round even impacted. The entire salvo, first round to last round impact, would span less than 40 seconds. Stay with me, because what happens in the next sequence eliminates the most expensive air defense asset Russia had protecting northern Crimea. The targeting package GMLRS-ER assembled for this strike was among the most detailed Ukraine had built for a Crimean air defense target. It started with satellite imagery. Multiple commercial imaging passes over several weeks established the battery's baseline dispersal geometry. Analysts measured distances between launcher positions, identified revetment locations, and recorded the precise coordinates of the engagement radar mast. Satellite imagery alone wasn't enough. A battery of this value would almost certainly have moved its elements, even slightly, between imaging passes. Russian doctrine required periodic position shifts specifically to defeat fixed coordinate targeting. GMLRS solved this through layered intelligence fusion. Satellite imagery established the baseline. Signals intelligence collected from assets tasked against the battery's emission profile confirmed when the radar was active and provided azimuth data that helped triangulate the engagement radar's precise location even after position adjustments. Human intelligence from within the peninsula, sources whose identities remain protected, confirmed the battery hadn't conducted a major displacement in the weeks before the strike. The third layer was drone reconnaissance. Ukraine's SBU and GMLRS both operate long-range drone assets capable of penetrating Crimean airspace at low altitude, using terrain masking along the northern peninsula's shallow ridgelines. A reconnaissance drone operating at approximately 80 meters above ground level overflew the battery's position during the 48 hours before the strike. Its imagery was transmitted in near real time to the targeting cell. What the drone imagery confirmed was critical. The battery hadn't displaced. The 4 launchers remained in their established positions. More importantly, the imagery showed a logistics vehicle, a 5T-58 2-transloader, positioned between 2 of the launchers. A transloader between launchers means one thing: a reload cycle was either in progress or imminent. The targeting cell transmitted its assessment up the chain. How many Russian vehicles did Ukraine destroy or damage in the broader Crimean air defense suppression campaign during this period? A 23B-38 C-50? The answer is coming before the end. Stay with us. The HIMARS battery tasked with executing the strike had been operating from a position in Kherson Oblast for several weeks. The crew, a unit whose designation EastAlert will not specify for operational security reasons, had conducted 17 previous strike missions. Their planning cycle for this target had been running for 11 days. The planning challenge wasn't simply identifying the aim points, it was sequencing them. Striking the S-400 required simultaneous destruction of multiple elements to prevent the system from engaging the incoming rockets. The engagement radar was the first priority. Destroy the radar and you blind the engagement chain. The command post vehicle was second. Destroy communications and you isolate the launchers from any surviving radar picture. The launchers were third. With the radar gone and the command post destroyed, surviving launchers couldn't coordinate an engagement. But the HIMARS configuration the Ukrainian crew was working with had a practical salvo limitation. The M31A1 GMLRS-ER rockets were being ripple-fired in a 6-round salvo. 6 rockets, 6 aim points. The crew and targeting cell had to decide which 6 of 8 potential aim points across the battery's dispersal received the first salvo. The targeting cell made the call: engagement radar, command post, 2 of the 4 launchers. Specifically, the 2 the transloader was positioned between, indicating those 2 were in a degraded ready state, and 2 additional precision aim points covering the battery's primary generator element and the 55K6E vehicle. Subscribe to EastAlert if you want to understand how modern warfare actually works. This is the doctrine that textbooks are being rewritten around. The HIMARS crew received the final targeting package at approximately 11:40 p.m. Weather over the launch position was acceptable. Moderate wind from the northwest, temperature several degrees above freezing, ceiling high enough to be irrelevant for ground-launched precision rockets. The crew confirmed GPS timing synchronization, verified the fire mission coordinates against the targeting package, and ran through the pre-launch checklist. At 11:52 p.m., the command post vehicle gave the fire order. The M142 HIMARS launcher elevated its pod. The first M31A1 GMLRS-ER rocket left the tube at 11:53 p.m. and 22 seconds. The second followed at a 4-second interval. Third, fourth, fifth, sixth. All 6 rockets were airborne within 22 seconds of the first launch. The launcher began its immediate move. Standard HIMARS doctrine after a fire mission requires the vehicle to displace within 90 seconds to avoid counter-battery fire. The crew had the launcher moving before the last rocket's motor had finished burning. 160 kilometers away, the S-400 battery was in its reload cycle. 2 of the 4 launchers had their masts lowered. The transloader crew was working in the dark. Russian battery discipline prohibited white light use at night, using red-filtered headlamps to maneuver the canister assembly. The reload was approximately 6 minutes into its 14 to 18-minute window. The 91N6E acquisition radar was running in search mode, its antenna rotating at standard scan rate. The engagement radar was in standby, its crew waiting for the reload to finish before resuming full operational readiness. Nobody in the battery had any indication the rockets were coming. Here's what the GMLRS-ER does that Soviet-era air defense engineers simply didn't design against. The rocket's terminal guidance package, a GPS/INS coupled seeker, provides sub-meter accuracy at full range. Unlike a ballistic projectile, the GMLRS-ER adjusts its flight path continuously in the terminal phase, correcting for GPS drift and updating its aim point from stored coordinates. The warhead is a 90-kilogram unitary fragmentation charge, optimized for destroying radar arrays and soft-skinned military vehicles. The engagement radar is a precision instrument. Its antenna assembly, transmitter, electronics, and cooling systems are designed to survive electromagnetic interference and some forms of physical shock. They're not designed to survive a 90-kilogram fragmentation warhead detonating within 5 meters. At 11:56 p.m. and 38 seconds, the first rocket impacted 6 meters from the base of the 92N6E engagement radar's antenna mast. The overpressure wave shattered the antenna assembly. The blast peeled back the forward face of the radar housing. The transmitter array was destroyed by secondary fragmentation. The cooling system ruptured. The radar stopped functioning before its operators could register what had happened. 4 seconds later, the second rocket hit the 55K6E command post vehicle. Its armor, designed to protect against artillery fragmentation, was inadequate against a direct precision strike. The blast killed the 2 operators inside and destroyed the communication suite connecting the battery to its higher command network. Third rocket, the number 1 launcher, mast down in reload position. The warhead detonated above the launcher's rear vehicle body, directly over the canister assembly. The explosion initiated the propellant in the 48N6E3 missiles still in their canisters. The secondary detonation was visible from Russian positions 8 kilometers to the north. Fourth rocket, the number 2 launcher, also in reload position, struck from above. Same result. Canister propellant initiated, secondary explosion, the launcher reduced to burning wreckage. What do you think? Could Russia have designed a different deployment posture that would have protected this battery from precision rocket strike? That's not a rhetorical question. Military doctrine analysts have been arguing about exactly this since the engagement. Comment your answer. Fifth rocket, the 91N6E acquisition radar vehicle. The blast destroyed the antenna assembly and set fire to the generator trailer attached to the radar's primary power system. Sixth rocket, the primary generator element, 180 meters from the acquisition radar. Destroyed. 11 seconds. 6 rockets. 4 aim points scored direct hits. 2 additional aim points produced confirmed kills. The 2 launchers that had been vertical and ready when the salvo arrived. Launchers 3 and 4 were undamaged by the initial salvo. Their crews survived. But without the radar, without the command post, without communications, and with 2 of the battery's 4 launchers burning around them, the surviving crew had no way to engage anything. Satellite imagery analysis conducted within 4 hours of the strike confirmed. 4 launcher vehicles destroyed, the engagement radar destroyed, the command post vehicle destroyed, the acquisition radar vehicle destroyed, the primary generator element destroyed. The 2 surviving launchers were assessed as combat ineffective due to the loss of all supporting systems. Total destruction value, approximately $1 billion at assessed replacement cost. Ukrainian sources estimate between 18 and 27 killed and wounded among the battery crew, with the highest concentration of casualties around the command post and the number 1 and number 2 launcher positions. The reload crew working between the launchers when rockets 3 and 4 impacted suffered the worst losses. Combat footage verified by OSINT investigators confirmed the transloader vehicle was destroyed, with secondary explosion debris scattered across roughly 200 meters from the launcher positions. If you believe tactics win wars, not just numbers, not just equipment, type EastAlert in the comments. This is what precision warfare doctrine looks like when it's executed correctly. Russia's response illustrated the confusion that follows the sudden destruction of a billion-dollar asset. Intercepted communications, reported through Ukrainian intelligence channels and corroborated by OSINT analysis of Russian Telegram military channels in the hours after the strike, revealed the outline of what happened inside Russian command structures. The initial report to the Brigade Air Defense Command indicated a major equipment malfunction, not a strike. The surviving crew, communicating via personal devices because the command post was destroyed, reported impact flashes and secondary explosions. Higher command initially interpreted this as either a ground accident or a Ukrainian drone strike. The distinction matters tactically. A drone strike implies a sensor-evading threat that might return. A HIMARS strike implies a targeting cycle that's already complete. Russian response protocols for these 2 scenarios differ. The confusion about what had actually happened delayed dispatch of a quick reaction force to the battery location by approximately 35 minutes, during which the fire continued to burn and secondary explosions from initiated missile propellant posed hazards to any recovery effort. By the time Russian forces arrived, the operational situation was unambiguous. The battery was gone. The command implications were immediate. The S-400 battery had been the primary air defense node for the northern Crimean corridor. Its destruction created a coverage gap. Airspace now accessible to Ukrainian strike assets without the threat of engagement from the highest-tier Russian surface-to-air missile system in the area. Russia tried to compensate with the Pantsir S-1 batteries forming the shorter-range close-in layer. But the Pantsir's engagement envelope, optimized for targets out to approximately 20 kilometers, couldn't replicate the strategic coverage depth the S-400 had provided. Ukrainian strike planners now had a window to approach Dzhankoi's logistics infrastructure from the north with reduced exposure to the highest-tier threat. The obstacle that almost prevented this strike wasn't Russian air defense. It was the 3-week period during which drone reconnaissance showed the transloader absent from the battery position. Without the transloader, intelligence analysts couldn't confirm when the next reload cycle would occur, or whether the battery had shifted to an extended ready posture that might mean launchers staying vertical for days. The targeting cell considered striking on fixed position intelligence from the satellite and SIGINT picture alone, accepting a lower probability of catching the battery in a degraded ready state. The GUR element coordinating the operation made a different call. They waited. For 22 days, the HIMARS crew held their position. The targeting package was kept current, and drone reconnaissance runs went out every 48 hours to monitor for the transloader's reappearance. On the night the strike executed, the transloader had been in position for less than 4 hours when the targeting cell transmitted the fire order. 22 days of waiting for a 14 to 22-minute window. The battery was gone. The northern Crimean air corridor had a hole in its coverage. But the strategic consequences extended beyond the immediate destruction of a single air defense asset. What happened in the days that followed? When Russian command scrambled to fill the gap and made 3 decisions that compounded the original disaster, is where the real doctrinal lesson sits. The first Russian response was predictable and, in retrospect, damaging to their coverage posture. Command ordered a second S-400 battery, one positioned to cover the eastern Crimean approaches near Feodosia, to displace and reposition to cover the northern corridor gap. This required a 120-kilometer road march across the peninsula. During a road march, an S-400 battery is combat ineffective. Its launchers are stowed for transport. Its radars are folded. A battery in road march configuration is vulnerable to exactly the kind of strike that had just destroyed its predecessor. Ukrainian reconnaissance tracked the displacing battery throughout its road march. The question for the targeting cell was tactical. Was the displacing battery itself a priority target? Or was the higher value objective the logistics infrastructure now temporarily exposed? The targeting cell chose the logistics infrastructure. With the northern coverage gap open and the replacement battery still 60 kilometers from its new position, Ukrainian strike assets executed 2 additional HIMARS missions targeting Dzhankoi's rail switching yard. Satellite imagery analysis by open-source investigators indicated destruction of a locomotive maintenance facility, significant damage to 2 rail switching assemblies, and the confirmed destruction of a freight consist that Ukrainian sources assessed as carrying artillery ammunition. The doctrinal problem runs deeper than the physical destruction. The S-400 Triumf was marketed to Russian export customers and to Russian military planners themselves as a system capable of defeating exactly the threat profile that destroyed this battery. The technical specifications for the 48N-6E3 interceptor missile list capability against ballistic targets at ranges up to 250 kilometers. The system's proponents argued it could engage cruise missiles, ballistic missiles, and even tactical aircraft at ranges that made it essentially untouchable by anything short of a strategic strike. What those specifications don't address is what happens when targeting intelligence is sufficiently precise to strike the battery itself before it can engage. The S-400's maximum engagement altitude and range are irrelevant if the targeting cycle for the incoming weapon is complete before the battery's crew registers the threat. The GMLRS-ER doesn't have a radar cross-section signature that reliably triggers an engagement chain. It's small, roughly 4 meters in length, under 250 kilograms total weight, and its terminal approach geometry at Mach 2.9 gives the battery's crew, if they do detect it, approximately 4 seconds to respond from initial radar contact to impact. 4 seconds is insufficient to complete an engagement authorization cycle under Russian battery SOP. What would NATO have done differently? Would Western air defense doctrine have positioned the battery differently? Perhaps with greater dispersion or with organic counter-battery radar to detect the HIMARS launch? Comment your tactical analysis below. The answer to the doctrinal question, can the S-400 defend itself against GMLRS, is effectively no. Not because the system lacks engagement capability against small, fast targets in principle, but because the operational geometry of a HIMARS strike from 130-plus kilometers, combined with the rocket's low radar cross-section and the engagement radar's standby status during reload, creates a combination the battery's self-defense doctrine doesn't adequately address. Russian air defense planners knew this in theory. The gap between knowing a vulnerability exists and actually fixing it is where doctrine goes to die. The broader consequence of this strike wasn't just the battery's destruction or even the temporary exposure of the northern Crimean corridor. It was the signal it sent about Ukrainian targeting methodology. Before this strike, Russia had some confidence that the S-400's operational security measures, emission control protocols, position-shifting procedures, radar standby discipline, provided meaningful protection against Ukrainian precision strikes. Russian doctrine assumed that the combination of these measures made it difficult for Ukraine to build a targeting package with sufficient accuracy and timeliness to execute a strike before the battery could displace. This strike showed that assumption was wrong. GIOR and Ukrainian military intelligence had developed a targeting methodology capable of maintaining a targeting quality track on a hardened, emission-controlled, position-shifting Russian air defense asset for weeks at a time. They had combined satellite imagery, SIGINT, and drone reconnaissance into a fused picture that could identify the battery's reload window with enough confidence to execute a strike inside it. For Russian air defense crews across the theater, this wasn't an abstract lesson. The implication was direct. Your operational security measures, which you've been trained to rely on, are insufficient to prevent Ukraine from building a targeting package against you. OSINT investigators tracking Russian military telegram channels noted a significant increase in posts from Russian air defense personnel discussing position-shifting frequency and emission control procedures in the weeks following this strike. Even in partially censored form, the information indicated the strike had triggered a theater-wide reassessment of S-400 and S-300 battery survivability. Ukrainian sources estimate that at least 3 additional Russian long-range air defense batteries in Crimea and the adjacent mainland conducted unscheduled position displacements in the 4-week period following the Dzhankoi strike. Each displacement degrades the battery's operational effectiveness. The crew accumulates fatigue, the maintenance cycle is disrupted, and the new position requires a fresh reconnaissance cycle before the battery achieves full operational capability. Every displacement is a small degradation. Enough of them, and the system can no longer provide the coverage its commanders believe it's providing. The cost-exchange ratio EastAlert has examined in previous breakdowns is relevant here. 1 HIMARS fire mission, 6 GMLRS-ER ER rockets at approximately $170,000 per rocket, costs roughly $1.02 million in ammunition. Against a target valued at $1.3 billion, the exchange ratio is approximately 1,270 to 1 in Ukraine's favor. Even accounting for the full intelligence collection cycle, the sustained drone reconnaissance flights, and the HIMARS battery's operational costs over the 22-day holding period, the exchange ratio remains overwhelmingly favorable to Ukraine. This is the arithmetic that drives Ukrainian targeting prioritization. High value, fixed signature, limited mobility Russian systems, air defense batteries, command posts, ammunition depots, logistics hubs represent targeting opportunities where the exchange ratio is orders of magnitude favorable to the precision strike attacker. Real tactics, real consequences. EastAlert. The S-400 battery's destruction at Dzhankoi was also a direct consequence of a doctrinal choice Russia made years before this conflict began. Russian military-industrial doctrine prioritized capability. The raw performance specifications of the S-400, its engagement range, its interceptor velocity, its resistance to jamming, over survivability against the specific threat of precision rocket artillery strike. The system was designed to defeat threats from aircraft and ballistic missiles attacking Crimea from the north. It was not designed to survive being targeted by precision strike systems operating from 130 kilometers away. When the threat changed, when Ukraine acquired HIMARS and built the intelligence infrastructure to support precision targeting, the S-400's design priorities became a fatal liability. This pattern appears throughout the history of complex weapons systems. Systems optimized for their stated mission often create different vulnerabilities that adversaries find and exploit. The fixed radar emissions that made the battery effective at acquiring threats also made it trackable. The reload cycle that maintained the battery's magazine depth created a predictable window of reduced readiness. The asset's high value created pressure to keep it operational rather than displacing it more aggressively. Ukraine, working with Allied intelligence support and its own growing capacity for persistent surveillance of high-value targets, built a targeting methodology that exploited all three of these characteristics simultaneously. Here is something that doesn't appear in the official readouts. The drone operator who conducted the final pre-strike reconnaissance pass, the pass that confirmed the transloader in position and triggered the fire order, maintained his feed on the battery position until approximately 90 seconds before the first HIMARS rocket impacted. In the drone footage, reviewed by SIGINT investigators in the hours after the strike, you can see the reload crew working between the number 1 and number 2 launchers, red-filtered headlamps moving between the vehicles. The transloader's arm extended toward the canister position. People doing their job, in the dark, in an occupied territory, with no warning of what was coming. The narrator does not editorialize about this. The drone operator was doing his job. The HIMARS crew was doing their job. The targeting cell was doing their job. War is a system in which people doing their jobs produce outcomes that, at a sufficient distance, look like strategy. At 11:56 p.m., the system produced its outcome. Will the exposure of this targeting methodology, the combination of SIGINT queuing, commercial satellite imaging, and low-altitude drone reconnaissance that enabled this strike, force Russia to fundamentally redesign how it deploys long-range air defense in occupied territories? Comment yes or no. The doctrinal shift is already visible in the evidence. What you think will happen next matters. Now for the answers and the tactical ledger. The answer to our earlier quiz: Ukrainian operations against Russian air defense infrastructure across Crimea and the adjacent mainland during this same period, as tracked by SIGINT investigators and confirmed through Ukrainian General Staff reporting, resulted in documented destruction or severe damage to components of approximately 38 air defense-related vehicles, systems, and support elements. That is answer B, 38. The number includes launcher vehicles, radar systems, command post vehicles, transloader and maintenance vehicles, and generator elements across multiple sites. The Dzhankoi battery accounted for 8 of these: 4 launchers, the engagement radar, the acquisition radar, the command post vehicle, and the generator element. The tactical lesson from this engagement comes down to 3 points. First, emission control is insufficient protection for a high-value fixed signature asset when the adversary has SIGINT collection capacity. The S-400's radar emissions were the thread that Ukraine pulled to locate, characterize, and time this strike. An asset that cannot function without emitting and that emits a distinctive signature cannot be protected by emission control protocols alone. It must either move aggressively enough that its position can't be fixed, or it must be defended against the specific threat of precision strike. Second, the reload window is a doctrinal vulnerability the S-400's designers didn't adequately address. A system that reduces its own kinetic effectiveness during a predictable and observable maintenance cycle creates exactly the kind of targeted vulnerability a sophisticated adversary will exploit. The solutions: staggered reloads, organic counter-battery radar, increased position shift frequency were known. They weren't implemented in time. Third, the cost-exchange ratio that HIMARS delivers against high-value Russian air defense assets creates a targeting priority that Ukraine and its partners will keep exploiting. 1 fire mission, 6 rockets, $1.02 million against a $3 billion target. The math doesn't change regardless of how many times this lesson gets delivered. Was waiting 22 days the right call? Or should the targeting cell have struck on fixed position intelligence and accepted a lower probability of catching the battery in a degraded ready state? Could Russian battery command have prevented this with a more aggressive position shift cycle, even at the cost of crew fatigue and reduced operational effectiveness? And if you were the commanding officer of a Russian air defense battalion in Crimea the morning after this strike, what orders would you have given your crews? Subscribe to EastAlert, because we break down the battles that textbooks will study for decades. The ridgeline northeast of Dzhankoi is quiet now. The site has been cleared. Russian recovery crews removed what could be salvaged and buried what could not. Satellite imagery shows disturbed earth where the launcher revetments were, and a rectangular scorch pattern where the #1 launcher's secondary explosion marked the soil. The wreckage is gone. The coverage gap it created is not. Northern Crimea's air defense architecture has not recovered to its pre-strike depth. The replacement battery, repositioned from the eastern sector, covers the northern corridor but has degraded the eastern coverage in turn. The cascading consequence of one well-executed HIMARS mission, 22 days of patience, 6 rockets, 11 seconds, is still working its way through the Russian air defense posture in a peninsula they believed was secure. The S-400 was supposed to be untouchable. The HIMARS proved otherwise. Real battles, real tactics, real consequences. EastAlert.